Okay, here's our demo for ML for leakage detection team. So for our hardware setup, we have a Raspberry Pi 4 connected to a ArduCam breakout board, which is a pre-built camera board for two cameras that we are attached to the Pi. Here's the source repository for those cameras. There's a bunch of Python and C files that are unimportant for this demonstration, but it goes over the introduction and how to install the SDK driver and to get the camera set up. Here is a information page about these cameras and all their hardware information, such as their resolution, which is 4K, active pixels, their field of view, etc. Uh, Here is a picture of setup, our live view rather. Here's the Pi 4 on the bottom here, connected to a RDCam breakout board with screws. And here are the cameras. These are the cameras that will be taking pictures of the critical piping
So for once we set up these cameras, we connected our Raspberry Pi to via VNC viewer to our computer, so we can run it remotely. Here we have this automation script where we mount our drive and then run it. Currently, we're just running one time for the demo purposes, but we run our leakage.sh, which takes the pictures and puts it into this folder. And wait, it takes a picture every 12 seconds and then waits for 3 seconds before retaking the pictures because it turns off the camera and reboots it. Um, so and then after it's done doing that, it waits for 2 more seconds and then sends it to the Google Drive that we mounted before, and then keep doing it as long as we want. We can just change it to an infinite number or just change it to different ways, and it will run it infinitely. So here I have opened up the ML folder to see the pictures are being taken because the preview I omitted the preview, so there won't be any preview. So let's go and run it. So as you can see, it started running it. It takes about 15 seconds to take a picture, which is quite a bit, but if we move any further faster, it was drawing out too much power because of turning on and turning off. So we ended up doing 15 seconds. That's another reason why we didn't want for the live video because it was overheating the Raspberry Pi and it crashes after a while, which is not good. This is the way we can make it go longer period of time with the more accurate pictures and stuff. So here we can see the pictures are populating. Once we have 6 pictures, it sends those 6 pictures to the ML so the ML can process that. The more idea of the ML will be described by our other coworker, Daniel. He developed the whole API for us. So uh, that's the part that detects if there is a leak or not based on the pictures taken. Currently, we're just taking the pictures of just the open area to see if it differs from the previous one. But in future, once we set up the proper, based on the situation, when we set up it, we'll be able to do the same thing that we intended to. So once we get this 6 picture, we should see them sending it to the Google Drive. As we can see, all the pictures are here. Now it's trying to send them to the Google Drive that we mounted before right here. As we can see, all the pictures are going one by one. So once that's done, we can come here and we can see, as we can see, we just sent it right here, 1 MB each. That was another reason Raspberry Pi doesn't come with the bigger memory. We're currently using 16 GB version, which is still not a lot. Currently there are only 3 gigs of space left. So once we receive all the images from the Raspberry Pi to our Google Drive, we go ahead and mount that Google Drive to our Jupyter Notebook here that we created. This Jupyter Notebook uses sklearn and other clustering algorithms like k-means, where we create a histogram of each images and compare those histogram with the original images histogram and create a margin. If the margin is above a certain degrees, can we consider it to be leaking or not leaking? The test output is right outside here where we're missing some of the images, but it has a couple initial images that we used it to run this algorithm. And as we can see, once we figure out which one is leaking, it will tells us if joint 1 is leaking or joint 0 is leaking. And that's pretty much how our overall system works.